Today in class we talked about designing spinners and how different spinners might have different probabilities. So today you're going to complete page 4 for homework and correct it with this option. Make sure you've had a chance to do your spins with your paperclip. In order to answer question 1, you need to have completed your trials. So I'm just going to kind of make up some data for myself here. I'm going to say I spun red 6 times, blue 12 times, and then yellow, since it's a total of 30 times, I'm going to say I got yellow 12 times as well. Now, again, I'm just making up some data here. Your data will probably look different. And so then I'm going to write my experimental probabilities for blue, red, and yellow. So remember, we're practicing probability notation also. So P red equals 6 out of 30. Again, this is for me. This is based on my data. Whatever data you have, it might be different. For me, my chances of getting blue is 12 out of 30. And for me, my chances of getting yellow was also 12 out of 30. And if you can simplify those fractions, go ahead and do that too. So now that we've done the experiment, let's think about the theoretical probabilities for red, blue, and yellow. So what fraction of the spinner is each color? Well, remember we talked today about how if I'm seeing the spinner, I need to envision breaking it to pieces of the same size. So for example, over here I can see that there's 3 pieces that kind of make up half of the spinner. And over here I see one piece here that looks like it's about a third. This red piece here needs to be broken up a little bit so that I can see all pieces of the same size. And so when I do that, I see a total of 6 different pieces. So that gives me my fraction denominator for the total number of outcomes. So now I'm going to write the actual probabilities. So my chances of getting red, for example. Well, looking for red here, I see red right here, and right here as well. So I see red 3 out of 6 times, or half of the time. I see blue 2 times, 2 out of 6, or 1/3 of the time. And I see yellow 1/3 of the time. Do you expect the experimental and theoretical probabilities to be the same? Why or why not? Well, looking at the probabilities that I had, they did not exactly match. And so thinking about this question further, I might talk about how after only 30 trials, they may not be the same. You might have gotten the same things, who knows, depending on your experiment. However, if we continued the trials, we're going to get to that in the next question. So again, think about if yours turned out similarly or differently, and you can kind of explain that based on your experimental probability. So suppose you spin 300 times instead of 30 times. Do you expect your answers to become closer to or further from the theoretical probabilities you found? As we do more trials, we expect to get closer to the theoretical probabilities. So think about this in terms of the experiments that we've done in class. So for example, when we did the experiment where we flipped coins, heads and tails, we expected to get heads and tails 50% of the time. Some of us didn't get that when we started, but as we added more and more and more trials on, we got closer and closer to that theoretical probability. So more trials is always better when it comes to thinking about the experimental and the theoretical coming closer to matching. When you spin, is it equally likely that you will land on red, blue, or yellow? Again, we know our chances of landing on red are 1/2 or 3 out of 6. Blue is 1/3 and yellow is 1/6. So are those all the same chances? No. So no, the chances of landing on each color are not equally likely. We're much more likely to land on one color than another. Suppose you use the spinner to play a game with a friend. Your friend scores a point every time the pointer lands on red. To make the game fair, for what outcome should you score a point? Well, you know again that red is half of the spinner. So if they get a point for landing on red, which again makes up half the spinner, how can you get a point for the other half the spinner? So you might be thinking about how if blue was 1/3 and yellow was 1/6, if I got a point or you got a point for the spinner landing on blue or yellow, that would be 1/3 or 2/6 plus 1/6. That would be also 3/6 or 1/2 probability. So if your friend gets a point for red, you should get a point for blue or yellow. Suppose you use the spinner to play a 3-person game. Player A scores on yellow, player B scores on red, player C scores on blue. How do you assign points so the game is fair? So this is an interesting problem to think about. I would suggest thinking about what the spinner looks like just to start. So I'm dividing this into 6, and so you'll see here, this is going to be the section I'm going to treat as my yellow section, right, which is 1/6. I'm going to treat this part here as my blue, which is 2/6, and then this is my half that is red. So if I think about it, I want everybody to be likely to get the same number of points, right, even though some colors show up more frequently. So I'm going to pick a number here, and I know it's going to need to be divided up by 1, right, because there's one section. It's also going to need to be divisible by 2, since blue has 2 sections. And I also need to be able to divide it by 3, because red has 3 sections. And if you don't quite understand why, you'll probably see here in a minute. So if I think about what's a number that's divisible by 1, 2, and 3. Perhaps you might choose 6. You could also choose 12. There's different options. So I'm going to choose 6, for example. And so I'm going to say that the yellow section by itself is worth 6 points. That's going to mean, right, even though they only have a 1 in 6 chance, if they land there, they'll get 6. Over here with the blue section, I'm going to divide those 6 points in the 2 sections. So I'm going to make this worth 3 and this worth 3. So one blue section is worth 3 points. Because if you think about it, it has twice as many chances to be chosen as yellow. And then the red, how many points should I give that? Well, 6 divided by 3, I would get 2. So I'm going to give 2 points to each of those sections. So if you think about what we have here, yellow is 1/6, I'm giving it 6 points. Blue sections are 1/3, and I'm giving them 3 points. And the red section as a whole makes up a half. And I'm going to give each part of the red 2 points. So it actually kind of connects with those fractions that we found earlier. We will see you tomorrow to talk more about probability.